Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. And this is Exploration. Every week in Exploration, we discuss the fascinating world of science and its impact on society. And leading off, we're going to summarize some of the top stories of the past week. Our lead story today concerns the passing of Muhammad Ali. The world mourns the loss of this great hero, a role model for millions. Not only was he unmatched in the ring, he was also a firm fighter for social justice and equality. But it also puts into sharp focus Parkinson's disease, a disease which finally killed him just a few days ago. You know, I had a chance to meet Muhammad Ali about 20 years ago, and already you could see the ravages that this disease inflicted upon his brain. And now scientists just this week announced that they've been able to identify a mutation in a gene called TMEM230, which is involved with Parkinson's disease. Also, speaking about diseases of the brain, a new breakthrough is being made in Alzheimer's disease. There's a new theory about the origin of Alzheimer's disease, which is 180 degrees different from all previous theories being proposed about that disease. Some people think that Alzheimer's disease will be the disease of the century, especially as baby boomers begin to age and show the signs of dementia. And speaking about medicine, a new form of liquid biopsy is taking the world of health, especially cancer health, by storm. Many people are saying that liquid biopsies could revolutionize the way that we counteract cancers. In fact, many people believe that one day the word tumor will disappear from the English language because of this revolutionary new device called liquid biopsies. And then we're going to go into outer space. The Europeans have a satellite that's testing Albert Einstein's theory of general relativity, paving the way for LISA. LISA, to be launched a few decades from now, is a gravity wave detector based in outer space. That's right, it's a space-based gravity wave detector. Not only will it give us detailed information about the center of a black hole, it may also answer the question of all questions, and that is, why did we have a Big Bang, and what happened before the Big Bang? And speaking about astronomy, then we'll bring on our special guest today, astronomer Ken Croswell of Berkeley. Well, let's just jump right into some of the top stories of the past week. The whole world mourns the passing of this great hero, Muhammad Ali. He was a role model for millions of people, especially because not only did he have athletic prowess, but he also was a firm fighter for social justice and equality, and the world will certainly miss him. However, the passing of Muhammad Ali brings into sharp focus Parkinson's disease. As I mentioned, I had a chance to actually meet Muhammad Ali, about 20 years ago. And already you could see that he was slowing down, his words were mumbled, and the fire in his eyes was beginning to become extinguished. But now scientists are beginning to understand that Parkinson's may have several origins, each one requiring a different kind of therapy. First of all, a rare form of Parkinson's disease is caused by overactive neurons in the brain, a cluster of these neurons. And by inserting tiny electrodes into the brain, you can actually desensitize that small area of the brain which is responsible for causing tremors and shaking of the hand. So this is one way to attack Parkinson's, but there are many other ways in which Parkinson's disease manifests itself. Another way is through mutations. Now, many times scientists have announced that they found the Parkinson's disease gene. Each time it was not possible to verify the claim. This time, scientists think that they really have it. They really have the gene that, when mutated, is responsible for one form of Parkinson's disease. The gene that is mutated is called TMEM230, And when it's mutated, it affects the dopamine channel of the neurotransmitters. Our nervous system looks like a telephone system, and it has connections between wires. Neurotransmitters are chemicals that speed up the transmission of a signal from one wire to the next wire, making it possible to transmit neural signals across the brain. Dopamine is one of the most important of all neurotransmitters, and it's involved with Parkinson's disease when the production of dopamine is abnormally low. Sure enough, the mutated TMEM230 gene causes a reduction in the production of the neurotransmitter dopamine. However, other people think that environmental causes may also be partly responsible, specifically traumatic blows to the head. And this is a cause of concern, especially for young parents who may want their children to go into athletics involving trauma to the head, for example, football as well as boxing. Well, at the present time, there's no one cure for Parkinson's disease. However, we have tantalizing clues in terms of being able to overcome the overactivity of localized neurons of the brain, also being able to find the neurotransmitters whose transmissions are adversely affected in Parkinson's disease. But at the present time, we do not yet have a cure-all for Parkinson's. However, some people think that yet another brain disease may be the disease of the century, and that is Alzheimer's disease. With baby boomers hitting retirement age, we may see an epidemic in this form of dementia that could ravage the brains of tens of millions of people. However, there's a new theory as to what causes Alzheimer's. First of all, Alzheimer's is typified by the production of a gummy plaque in the brain called amyloid protein. We also have the tau protein as well. And so there's several proteins that gum up the brain. Now, the question is it the cause of Alzheimer's or is it a byproduct of Alzheimer's disease? We don't know. But many of the current ways of tackling Alzheimer's is to try to tackle the gummy amyloid protein. For example, many pharmaceuticals have already invested millions of dollars to create a vaccine that would limit the production of the amyloid protein. Now comes a new theory which says, wait a minute, perhaps we're barking up the wrong tree. Perhaps the amyloid proteins are not the cause of Alzheimer's at all. This new theory, which is gaining a lot of traction recently, states that it's actually an infection, perhaps a virus, which sets into motion our immune system. Now, autoimmune diseases are triggered when the body overreacts by creating things which actually cause more debilitation of the body. People think, for example, that certain forms of arthritis may be caused by an autoimmune response, with the body overreacting and basically attacking itself, creating arthritis. Well, the theory is as follows. When you're infected with certain kinds of germs, the body produces a gum which encapsulates the germ, basically creating a prison that sequesters the germ from the rest of the body. And that gummy substance is amyloid protein. And yes, it's true. Amyloid proteins are the byproduct of the way in which the body encapsulates germs by imprisoning them in this shell. Amyloid proteins are so strong, in fact, they are pound for pound stronger than steel. That's how tough these amyloid proteins are. Now, to test this theory, scientists are beginning to look at the blood-brain barrier. For example, Alzheimer's afflicts elderly people. By the time you're in their 80s, a large fraction of a normal population of people will eventually come down with Alzheimer's simply because they're in their 80s. Now, why? It turns out that the blood-brain barrier, which prevents toxins in our blood from getting into the brain, begins to wear down with time. And it is especially weakened in the area of the brain called the hippocampus. The hippocampus is where short-term memories are stored, not long-term memories. So the theory goes that as bacteria builds up in our blood, the blood-brain barrier becomes weakest at the border between the blood supply and the hippocampus, allowing germs to leak into the hippocampus. Then the body marshals the amyloid proteins, it overreacts, encapsulates the germ, but then just keeps on going and gums up the hippocampus. Now, the brain, of course, has ways to clean out some of this amyloid proteins, but even that mechanism starts to break down with time. And the theory goes that's why Alzheimer's affects short-term memory first. You can have somebody with Alzheimer's disease that has perfect long-term memory, but they can't remember where they put their keys just a few minutes ago. That's typical of damage to the hippocampus because long-term memories are stored in different areas of the brain. For example, long-term memories could be stored over the entire surface of the brain, while short-term memories are concentrated and processed in a small little organ called the hippocampus. So if this theory is correct, it may explain several things. First, why is there so much amyloid protein being produced? It's being produced because the body is overreacting to an infection. Second, why does it affect old people? Because old people have a problem with the slow degeneration of the blood-brain barrier. Third, why is short-term memory the first to be afflicted? And the reason for that is because that's where the blood-brain barrier is weakest. That's where germs can hop across the blood-brain barrier and get into our brain, and then that sets off an immune response, and the body overreacts, creating this gummy material which causes Alzheimer's disease. Now, if this theory is correct, it means that perhaps we've been barking up the wrong tree. The bulk of research has been trying to eliminate the amyloid proteins. But perhaps a better way is to attack the disease itself. Perhaps scientists can one day isolate the diseases which are responsible for triggering this immune response, and thereby allowing scientists a method to control the disease without having to mucky around with the immune system. Well, it's still just a theory, but it's gaining a fair amount of traction among researchers in the field, and if it's true, it means perhaps we've been barking up the wrong tree, but new avenues of research will be opened up as a consequence. And speaking about disease, yet another breakthrough is being made, this time in terms of cancer detection. You know, actually curing all forms of cancers turns out to be much more difficult than we previously thought. The body, for example, contains roughly 200 different types of tissues. Each tissues, in turn, can undergo hundreds of different kinds of mutations causing cancer. So cancer, we know, is a disease of the genes. Whether it's caused by cigarette smoke, whether it's caused by a germ or a chemical substance, all of these things cause our genes to malfunction. These are the genes which control the replication process of the cell. So the cell begins to reproduce itself out of control, and that's what a cancer cell is. A cancer cell is nothing but an ordinary cell that has lost its ability to die. It is immortal. It simply reproduces itself forever, eventually killing the host. Now, a new way of controlling cancer may be not to cure all cancers, because there are thousands of different kinds of cancers, but to improve cancer detection using something called liquid biopsies. Now, biopsies, of course, are very expensive. They're time-consuming. It involves getting into the body itself and getting a piece of the tissue of a suspected tumor. But a liquid biopsy would simply analyze your blood. Wouldn't it be great to simply go to the bathroom, do a blood test, and find out whether or not you have cancer cells circulating in your body? No messy appointments with the doctor, no waiting period. You can basically do this in the privacy of your own bathroom. And that's the promise of liquid biopsies. In fact, in the future, when this is perfected, perhaps you'll simply go to the bathroom 3 times a day, and your bathroom will analyze your bodily fluids and tell you what is circulating inside your blood system. Already, the FDA, the Food and Drug Administration, has now given the green light for one form of liquid biopsies. This form of liquid biopsies is good for 70 different types of cancers. Now, again, we should caution you that this is still the early stages. The FDA has just given the green light for the first generation of liquid biopsies. And, of course, there's probably going to be false positives and bugs in the system. But eventually, this is going to revolutionize the way we view cancer. In other words, the word tumor could actually disappear from the English language. Think about that. You know, by the time you have a tumor, you have on the order of 10 billion cancer cells in your body. That's a huge number of cancer cells. However, a cancer colony may have only several hundred cancer cells in a cancer colony years before a tumor forms. And this cancer colony sheds genes, sheds proteins and enzymes that are characteristic of that cancer. So wouldn't it be great? Wouldn't it great to have an early warning system indicating that certain forms of cancer are growing in your body years before a tumor forms? And again, the technology is still in its infancy. Bugs will have to be ironed out. But eventually, when it reaches maturity, this could revolutionize the way we view cancer. In fact, personally, I don't think we're ever going to find one cure for cancer. It'd be simply too expensive to create a cure for the thousands of different kinds of ways in which mutations can form in our genes. We may eventually view cancer like we view the common cold. Think about the common cold. Why don't we cure the common cold? That's the first thing that kids ask. Well, there are over 300 varieties of the rhinovirus. We could do it. Yes, it is possible to cure the common cold. But the expense does not warrant it. And so that's the reason why drug companies do not want to get into curing every one of the 300 or so rhinoviruses that cause the cold. The same thing may happen with cancer. In the future, who knows for sure, but in the future we may cure outright a certain minority of cancer types. In other words, certain forms of cancer we will cure outright. However, for the bulk of cancers, we may simply live with them. And that is, we'll be able to detect them years before a tumor forms. We'll be able to take early action, and we'll simply live with it, just like we live with the common cold. In the future, very few people will actually die of cancer, but will simply live with it because it doesn't kill anyone, and it simply costs too much to cure all forms of cancer. And also news from outer space. Just a few months ago, the headlines were talking about the fact that gravity waves were detected 100 years after Einstein first predicted them in the year 1916. And that created a tremendous commotion among physicists because it opens up a new realm for telescopes. We have, of course, optical telescopes. That was pioneered by Galileo 400 years ago. And we also have radio telescopes. That was pioneered during World War II, when we had to be able to detect aircraft even at night using radar, microwaves, and other forms of radiation. This could represent the third major advance in telescope technology, gravity wave detectors. And we're going to put them into outer space. The European Union has just announced that they're going to send up LISA into outer space in perhaps roughly 20 years. LISA is the Laser Interferometry Space Antenna. It is 3 satellites separated by about 3 million miles, making a triangle in outer space. Laser beams then go back and forth along the lines connecting these 3 satellites. So think of a triangle in outer space. Each vertex of the triangle is a satellite. The lines making up the triangle is the laser. And the laser beams can be very sensitive and pick up vibrations initiated by the Big Bang or by black holes. LIGO, which is the gravity wave detector on the Earth, detected radiation from colliding black holes in outer space. So the collision of two black holes created gravity waves, just the way that you throw a rock into a pond. When you throw a rock into a pond, it creates waves of gravity, which then begin to emanate, and LIGO is sensitive enough to detect these things. LIGO is basically two laser systems based in Louisiana and Washington, sensitive enough to pick up the vibrations from black holes. Now, it turns out that the real game, of course, is the Big Bang. The Big Bang was this huge explosion which took place 13.8 billion years ago. And that radiation, believe it or not, is still circulating around the universe. Believe it or not, when you turn on an old TV set and you see that snow on the screen, that snow is actually caused in part not only by the planet Jupiter, but also the Big Bang itself. So believe it or not, that snow that you get from static actually comes from the planet Jupiter as well as radiation from the Big Bang itself. So Lisa may be just at the border of being able to detect radiation from the Big Bang itself. That is incredible. Now, we have baby pictures of the Big Bang, baby pictures of the explosion, about 300,000 years after the explosion itself. Go to nasa.gov, look under COBE and WMAP, and you'll see the pictures in microwave of the explosion. And it really does look like an explosion. You see ripples caused by the original explosion. Basically, this is a baby picture of the Big Bang 300,000 years after the initial explosion. But what's frustrating is we want to know what happened at the instant of the Big Bang, not 300,000 years after the Big Bang. For that, optical telescopes are useless. Optical telescopes simply pick up fuzz, this haze that took place 300,000 years after the Big Bang. To go to the very instant of the Big Bang, you have to look at gravity wave detectors. It turns out that LIGO, based on the planet Earth, is simply not sensitive enough to pick up the radiation from the Big Bang. What we need is a space-based system, a system which can pick up low frequencies, a system which is not contaminated by other kinds of disturbances. For example, LIGO is so sensitive, it can easily pick up vibration caused by nearby traffic, but also by nearby tides. Incredible. Waves caused by the Pacific Ocean can actually be detected by the LIGO detectors. And that's how sensitive they are, and that's why they have to be placed in outer space for the next generation of gravity wave detectors. Just like optical telescopes opened up the universe for intensive scientific study, just the way that radio telescope technology opened up galaxies and black holes for scientific investigation, many people believe that gravity wave detectors will open up the creation of the universe itself for scientific work. Now, what will we find? We might find evidence of a multiverse. We think that the universe is a bubble of some sort that's expanding. We live on the skin of the bubble. That picture is given to us by Albert Einstein, and that's called the Big Bang Theory. The Big Bang created a bubble which is expanding. But then the question is, what is the bubble expanding into? Well, the bubble we think is expanding into hyperspace, another dimension. In fact, string theory predicts 11 dimensions. And there could be other bubbles out there. String theory says that, well, our universe may not be alone. There could be other universes out there, and Big Bangs could be happening all the time. That's called inflation theory. And if Big Bangs happen all the time, It means that there could be multiple parallel universes out there. Each time a universe is created, perhaps it has different constants of nature, which is stunning because we think that the laws of physics are uniform throughout our universe. Well, that may be true for our universe. Our universe may have one law of physics, but there could be other universes with different laws of physics. For example, when we look at the instant of the Big Bang, and we look at the radiation that emanates from the Big Bang, we find that it's ordinary radiation. Radiation in the microwave range, just like what you get in a microwave tower, or the microwave that you find in your kitchen. So, in other words, the laws of physics 13.8 billion years ago are, to a large degree, the same as the laws of physics today. Our universe basically has one law of physics, given to us by the quantum theory and by relativity. But if there are parallel universes, they could have other laws of physics. Perhaps they don't have a periodic chart. Perhaps they have more elements than the elements that we find in our universe. Perhaps alien life can exist based on different kinds of chemistry. I mean, the brain goes crazy thinking about what you can do if you could actually alter the laws of physics to create a multiverse of universes. Well, of course, all this is speculation, but the real name of the game is LISA, gravity wave detectors based in outer space to listen in on the Big Bang. And maybe we'll find evidence of an umbilical cord. Well, then the next question that people ask me, if there are other universes out there, then the question is Elvis Presley still alive in one of these universes? Well, it can't be ruled out, given the fact that even the laws of physics themselves may be altered, and perhaps, who knows, there could be perhaps an infinite number of these universes. Well, all this, of course, is sheer speculation. That's why we have to build LISA. That's why we have to build these gravity wave detectors, which are powerful enough, we think, to begin to tease apart the origin of the Big Bang. Why was there an explosion? What exploded? And what set it off? And of course, what was there before the creation of the universe? These questions are fair game once we have gravity wave detectors based in outer space. Well, I'm afraid that's it for the first part of Exploration. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City College, and this is Exploration. Stay tuned now for the second half of Exploration when we bring on our special guest, astronomer Ken Croswell, who'll talk to us about some of the wonders of the universe. You know, we are understanding more and more about the nature of the universe, and each time we're surprised and shocked by the new wonders that science is revealing. And so once again, we're going to talk about the universe today with astronomer Ken Croswell of Berkeley, author of the book Magnificent Mars, Magnificent Universe, and many others. Well, with us today is Dr. Ken Croswell, astronomer at Berkeley, author of a number of great books, Magnificent Mars, Magnificent Universe, The Universe at Midnight, you name it, he's written about it. And Ken, let's start first of all with our own backyard, and that is the planet Mars. We've been hearing a lot about the planet Mars in terms of our rovers, which seem to have confirmed the existence of water flows on the red planet perhaps billions of years ago. But first of all, what would it like to actually be on the planet Mars?
Well, hello, Michio. Glad to join you. And yes, Mars is our second nearest planetary neighbor. Venus actually comes closer to us than Earth than Mars does. But modern Mars is a very hostile planet. Nevertheless, it's the best of all the planets that we know of in our solar system in terms of having Earth-like conditions. But if you were to visit Mars, you would definitely need a spacesuit because the atmosphere is incredibly thin. It's less than 1% the air pressure here on Earth, so it's very little air to breathe. And furthermore, most of the atmosphere of Mars is carbon dioxide, the same gas that we get rid of when we breathe. So there's essentially no oxygen in the air to breathe on Mars. And as you might imagine, because Mars is farther from the sun than we are, it's very cold on Mars. It's a very cold, very dry place. There's no running water that we're aware of, and it's I would describe it as a super Antarctica, raised to a very high altitude with incredibly thin air. And by the way, there's also no ozone layer on Mars, so there's nothing to protect you from the deadly ultraviolet radiation from the sun. So if that sounds like the sort of place you'd like to visit, well, go right ahead. But I think I'm going to stay right here on Earth.
Okay, now some people who believe that we should colonize Mars cheaply say that the pioneers were able to colonize the U.S. of A. by living off the land. They didn't bring water, they didn't bring supplies with them as they went across the Midwest out to California. They essentially, hunted and scavenged what they could. Now, on Mars, can you really live off the land? I mean, can you raise crops there? Are there animals to hunt? What is it like to try to, quote, live off the land on Mars?
Well, there certainly aren't any animals or plants on Mars, but people have suggested this idea that it would be a lot cheaper, a lot easier if we can simply send people to Earth and they will basically construct what they need out of what they find on Mars. I have no doubt that crops could grow in Martian soil if subjected to the right conditions. We know that the crops might even be healthier. We know that the Martian surface has a lot of iron, and that's what colors the planet. It's a vivid orange color. So the plants there actually might be healthier than the ones we grow here on Earth. But having said that, of course, there are huge challenges. The settlers to America didn't have to worry about finding water or finding air to breathe. Now there is ice beneath the surface of Mars. We know that, and so you could melt that ice and have water, but you're still going to have a problem with having enough oxygen to breathe. So I think it would be quite a challenge, and yet some people have suggested this, because if you have to bring everything that you need from Earth, it takes an enormous amount of energy to lift anything off of Earth and escape the Earth's gravitational pull. So you understand the concept here is that just to make it cheaper and easier to get away from Earth, the less you take with you, the easier it is to travel. I mean, same principles applies when you're flying. The less luggage you take with you, the easier it is. But of course, when you get to where you're going, you don't have as much stuff. And in the case of Mars, I think it would be a real challenge to do that. But there are some people who are suggesting that they could do it, and it's an interesting concept. That's all I will say.
Well, let me run this by you. Some Mars enthusiasts have said that we should give one-way tickets to the Red Planet. You would land on the Red Planet, and then a second unmanned rocket comes later, and it contains some rocket fuel. And plus, even on the surface of Mars, you could melt some of the ice, because Mars is a frozen desert. Take that water from the ice, take out the oxygen and hydrogen from the water, and then use that for rocket fuel for a return trip back. So here's the question. Would you want to go to Mars knowing that it's a one-way ticket and that you have to scavenge rocket fuel for the return voyage?
Well, personally, I would not, because I like it a lot here on Earth. But there are many people who would take you up on that offer. So I don't think there will be any problem finding people who want to do this. The real question is, will they survive or not? And I don't know. I mean, I don't think anyone knows. I'm not a rocket engineer. I'm an astronomer. So it's something that might happen later in the 21st century, though.
Okay. Now, some people who have analyzed the data from our Mars rovers roving on the surface of Mars, they find no evidence of liquid water, but there is tantalizing evidence that water once flowed freely on the surface of Mars, perhaps billions of years ago, and there could in fact be organic materials, maybe even evidence of life. So what are your thoughts about whether or not billions of years in the past Mars may have been in fact tropical, and perhaps microbial life may have survived then? What are your thoughts?
Well, definitely billions of years ago, Mars was a better planet than it is today. I doubt it was ever tropical, but it was. We know that that water did flow on Mars. We see in the oldest parts of Mars dried up riverbeds. We also see flood channels on Mars, so we know that water did flow on Mars many, many billions of years ago. The big question has been just how much milder was Mars many billions of years ago. There have been some people who have suggested that it may have been, tropical or at least warmer. I very much doubt that. I think what you're seeing in those riverbeds is rivers that probably only flowed occasionally when it got sufficiently warm to allow water to flow. In fact, there's a river in Antarctica that it only flows a few days every year. And it's entirely possible that ancient Mars may have been similar, that it was a very hostile place, very cold place, and only on rare occasions did it get warm enough to allow water to flow. But once you have liquid water in liquid form, then it's possible that some form of life could have developed. There's recently been a proposal, in fact, that maybe punctuated volcanism occurred on Mars. We know that volcanoes erupt lots of greenhouse gases, and according to this new theory, maybe when you had a lot of volcanic eruptions on Mars, it warmed Mars for a few centuries, and during that time, rivers could flow, and maybe, who knows, maybe some form of life could have developed on Mars.
Now, recently, there was a flash in the news stating that perhaps methane gas has been detected on Mars, and where there's methane, perhaps there are decaying organic materials, or perhaps it's a normal, naturally occurring chemical process. But what are your thoughts about the possibility that there could be methane gas on Mars, indicating perhaps the presence of microbial life?
Well, I'm very skeptical that there's any life on Mars today, even microbial life. I just don't think Mars is just such a very hostile place. So I think that methane gas, the very small amount of methane gas that has been found, probably has a non-biological explanation. So the methane alone does not convince me that there is some form of microbial life on the planet.
Okay, well, here's a wild theory. One theory says that Mars basically cooled off before the Earth. Earth was still molten while Mars was cooling off. Perhaps DNA got off the ground on Mars first as a consequence. Then perhaps meteors slammed into Mars during that period of time. And DNA, like a ping pong ball, began to go into outer space and seed the Earth. And then when these meteors containing DNA hit the Earth, it seeded the Earth, and that's where we come from. So if you want to see a Martian tonight, look in a mirror. What are your thoughts about that wild theory?
Well, it's a possibility. Certainly because Mars was a better planet 4 billion years ago, it's possible that some form of life developed there. We know that since Mars is a smaller planet, a less massive planet, it's much easier to launch material into space from Mars than it is from Earth. And therefore, if an asteroid slams into Mars, you're going to get a bunch of rocks kicked up. Some of those rocks will make their way to Earth, and indeed we have found a number of meteorites from Mars. And so it's conceivable that, if DNA formed on Mars, if some form of life formed on Mars, some of that life could have hitched a ride in one of these meteorites and made it to Earth and seeded the Earth. So it's possible. On the other hand, it's also possible that life on Earth arose right here on Earth. We didn't really need any help from the planet Mars. I don't see an easy way to test the idea, though, as to whether life on Earth arose or arose first on Mars or maybe even someplace else.
Okay, well, the president has said that perhaps by 2030 or so, there could be humans on the red planet. And then the question is, well, what do they do on the red planet? One possibility is to terraform it, that is, create a Garden of Eden on Mars by initiating a greenhouse effect. However, don't you think that that would be centuries away? It's not going to be easy to planetary reform the environment, right? What are your thoughts?
Well, I think you are talking about something that's not going to happen in the 21st century in terms of terraforming, because Mars is just, it's going to take a lot to terraform Mars to bring it up to a warm temperature. It's on average 52% farther from the sun than the Earth is, and so it needs a much larger greenhouse effect than we have here on Earth. The Earth has a greenhouse effect that raises our temperature about 60 degrees Fahrenheit. In other words, if we didn't have greenhouse gases such as water vapor and carbon dioxide in our atmosphere, the mean temperature of the Earth would be about 0 degrees Fahrenheit versus what it actually is, which is 60 degrees Fahrenheit. To raise the temperature on Mars, which is even colder, is going to take an even more substantial greenhouse effect. Now, there is a small greenhouse effect already on Mars. 95% of the atmosphere is carbon dioxide. Carbon dioxide is a greenhouse gas, and the greenhouse effect there raises the temperature about 10 degrees Fahrenheit, but that's just not nearly enough to make Mars a pleasant place to live. So, yes, if terraforming of Mars ever happens, we're talking much, much farther into the future. I think one of the big jobs of any astronaut going to Mars ought to be to look for fossils of ancient life on Mars, because that's something that, as we've been discussing, we really don't know what went on Mars 4 billion years ago, but we do know that it was a better planet back then. And so if life could have formed on Mars, it surely would have done so long ago. And so if astronauts can seek out fossils of that ancient life, that would be a major discovery. That would tell us that life had established itself on another planet besides Earth.
Now, quite a few years ago, there was a blip in the media stating that scientists have analyzed one of these meteorites that came from Mars. It really was a piece of Martian rock. It had all the right characteristics of Martian rock, and you cracked it open, and bingo, there were these little wormy things inside, and they created a tremendous controversy. Some people said, aha, this is evidence of microbial life. Other people said, well, no, it could be crystals, just naturally occurring crystals. But that was several years ago. What's the latest in terms of whether or not scientists believe that we've actually picked up evidence of life forms of Mars on the Earth?
That was in 1996 that claim was made, and it has not fared well in the years since. The people who are experts on this matter, most of them dismiss that claim. Now, what is true and is unquestionable is that we do have rock from Mars on Earth, because, as I mentioned, asteroids every now and then climb into Mars, and it's fairly easy to launch material into space from Mars because its gravity is weaker than the Earth's gravity. So so half of that claim is correct. I mean, the rock really is from Mars, but the people who are experts, I would say 98% of them do not believe that there is evidence for life in that meteorite. So that claim has not fared well with time.
Okay, well, moving farther into the solar system, let's now talk about meteors and comets. Recently, there was the Rosetta probe, which gave us rather sensational up-close photographs of a comet, and there was actually a close encounter, and they were able to actually land a probe on the comet. So here's an easy question. What is the difference between a meteor, a comet, and a meteorite?
Well, a comet is an object, a fairly large object that goes around the sun that contains a rock and water ice. And when one of these objects comes close to the sun, the ice vaporizes, and we see a spectacular tail to the comet. A comet is something that it doesn't just flash across the sky in a second or two. You can see it night after night after night. And, in fact, I'm sure many of your listeners saw Comet Hale-Bopp back in 1997 for many, many evenings. That was an absolutely spectacular comet. Now, in contrast, a meteor is simply an object that flashes across the sky, a flash of light that maybe lasts a few seconds. And there is a relationship between comets and meteors because as comets travel through space, they lose dust. And when those dust particles, which are called meteoroids, smash into the Earth's atmosphere, they burn up, and we see this spectacular flash of light called a meteor. And then a meteorite is a rock that actually makes it to the Earth's surface. Most of this stuff, which is good news for us, most of it burns up in the Earth's atmosphere, so we don't get hit by it. But every now and then, one of these rocks makes it to Earth, and once it lands on Earth, it's called a meteorite. So we have most meteorites come from asteroids, but some come from Mars, and others come from the Moon. So those are the three answers to your question: comets, meteors, and meteorites. Meteors come from comets, and meteorites are those few objects that actually make it through the Earth's atmosphere and land on Earth.
Okay. Now, also, people ask the question, well, why should I care? However, these objects are potentially dangerous, right? What happened over Russia, over Chelyabinsk, Russia, a few years ago, and for that matter, what happened 65 million years ago to the dinosaurs who are not here to talk about it?
That's right. These objects are potentially dangerous. And so what we'd like to do is to find all the objects out there that might impact the Earth and then see if we need to devise some strategy to deal with them. On the other hand, these objects also very likely brought benefits. The water that is now on Earth likely came from asteroids and comets impacting the Earth shortly after its birth. And in fact, this is probably the first real scientific result to come from the Rosetta mission to that comet, in that the scientists have analyzed the data, and they conclude that most of the water on Earth came not from comets, but instead from asteroids. So that is another reason we should care, not just that these objects can hit us, but also because without asteroids and without comets, we might not have the water that we need to make life possible here on Earth.
Okay, let's go over that point again, because that's pretty significant. On the planet Earth, roughly 3/4 of the surface of the planet is liquid water. However, liquid water is quite precious in the solar system, but where did all this water come from, given the fact we don't see too much water out there except in the form of ice? So you're saying that the water on the Earth probably came from asteroids, not comets. So when you drink water, you're actually drinking asteroid water. Basically,
yes. Here's the reason the existence of water, which we kind of take for granted, is a mystery on Earth. The Earth formed just 93 million miles from the sun. That's pretty close. And we know that the Earth and the other planets formed from a disk of gas and dust that went around the young sun. And that disk was quite hot, close to the sun. So the Earth formed in a fairly hot part of that protoplanetary disk. And so you don't really expect it to have incorporated much water. The water should have all vaporized. There really should not be much water on Earth at all. And yet, as you point out, most of the Earth's surface is covered by water. So the question is, where did it come from? And for a long time, there was a nice theory that comets delivered Earth its water, because comets fly in the outer part of our solar system. They're nice and cold, and they contain water ice. And every now and then, one of those hits the Earth and gave us our water. Well, if that were really true, then you would expect the composition of comet water to be the same as the composition of Earth water. And in particular, the comet should have the same deuterium to hydrogen ratio as Earth water does. Now, let me define deuterium. Deuterium is simply an isotope of hydrogen. Normal hydrogen has one proton in its nucleus and no neutrons, whereas deuterium has one proton and also one neutron, so it's twice as heavy as a normal hydrogen atom. And just as water, most water is H2O, but you can also have HDO or even D2O, in which deuterium takes the place of hydrogen. And if comets, in fact, supplied Earth with its water, then the deuterium to hydrogen ratio should be the same in comets as in Earth's water. And when the very first such measurement was ever made, back in 1980, when the most famous comet, Halley's Comet, passed by Earth, well, guess what? The deuterium to hydrogen ratio was twice what it is in Earth water. And so that was a blow to the theory. But it wasn't fatal, because hey, Halley's Comet is just one comet, right? Well, in the 1990s, two more bright comets came by, Comet Hyakutake in 1996 and Comet Hale-Bopp in 1997, and they also had twice the deuterium to hydrogen ratio as Earth water. So at this point, the water theory as coming from comets was in serious trouble, and with one exception, all the other comets that have been examined since have had higher deuterium to hydrogen ratios than Earth's water. And this, the most recent data comes from the Rosetta spacecraft, and now the scientists are reporting that the comet that the Rosetta spacecraft visited has the highest deuterium to hydrogen ratio ever measured in a comet, 3 times, more than 3 times the terrestrial level. And so this leads the scientists to conclude, just as you say, that most of Earth's water probably came from asteroids that hit the Earth rather than comets, because we do know that asteroids have deuterium to hydrogen ratios that are very similar to that in Earth's water. So it may be very romantic to think of comets as, these beautiful comets as supplying us our water, but the latest evidence suggests that it's actually these rather dull-looking asteroids that supplied most of the water on Earth.
And also the Rosetta probe made history because it was able to put a probe on the surface of a comet. Wasn't that remarkable? That we're rather sophisticated now in our celestial mechanics and navigation, that we can actually make a soft landing on a comet.
Yes, it definitely is. It definitely is a major achievement, and it's a first, and hopefully there will be more. Hopefully we can have more close-up views of comets in the future.
Now, recently, a few years ago, there was a press release issued by Google and Yahoo and Microsoft billionaires. These billionaires, as I recall, said that the next frontier is the asteroids, and we should mine them. There's money to be made, they said. And, of course, the question is, well, whose money is going to pay for it? These asteroids are very far away. But what are your thoughts? What are your thoughts about, quote, mining the sky? That is, at one point in the future, sending space probes that would then mine platinum-type alloys and materials on the asteroids.
Well, my very first thought is it's incredibly expensive to do something like that. And so what you mine, if you're really going to try to make money in this way, it seems to me what you mine is going to have to be incredibly valuable. So I'm not an economist. I don't know if the numbers work out, but it's just my instinct, everything I know about space is that it's expensive. I mean, for example, whenever we astronomers launch a telescope in space, such as the Hubble Space Telescope, it costs a lot of money, a lot more money than just building a telescope here on Earth. And so mining an asteroid is going to be a lot more expensive than mining minerals here on the Earth. And so I don't know. I mean, it seems to me you would have to have some pretty precious stuff on that asteroid in order to make it pay.
Yes, it cost about $1 billion to build the Hubble Space Telescope, and then when it was launched, it came out nearsighted. The optics were wrong, and they had to have a second $1 billion mission to put corrective lenses on the Hubble Space Telescope. Now,
yes,
also,
indeed.
What are your thoughts about the Sentinel program? That is, some scientists have advocated that we have an early warning system, that is, a series of telescopes in space that would identify near-Earth objects, that is, potential candidates for killer asteroids and killer meteors that might hit the Earth. So what are your thoughts about an early detection system that could give us maybe an insurance policy of some sort if something is coming our way?
Well, I think it's a good idea because that's something that would not cost so much money. We're not talking billions of dollars there. I mean, simply to discover all things out there that cross the Earth's orbit, you're probably talking a few $1 million to do that. And I think that's an excellent investment and an excellent idea.
Now, some people have pointed out that if you simply count the objects that are out there and then multiply by the volume of the solar system, there perhaps millions of small asteroids that could in fact eventually hit the Earth, and that if these tiny objects could be illuminated brightly in the night sky, the night sky would be littered with millions of these little dots passing the Earth, and you'd be shocked how much garbage and junk there is out there, even though outer space seems to be pretty much a vacuum. Well, I'm afraid that's it for exploration. Once again, our special guest today was astronomer Ken Croswell of Berkeley, author of a number of great books concerning astronomy.